Today we are going to look at solving problems on indices. Our first questions we are going to take using the laws of indices to solve is this. Now let's say evaluate the following. Evaluate the following using laws of indices. So 64 raised to power 2 over 3. 64 raised to power 2 over 3. Now let's say we are given a value like this, 64 raised to power 2 over 3. We are to make use of the knowledge we've got from indices. So what do we have? 64 raised to power 2 over 3 can be written as 64, the cube root of 64, raised to power what? Raised to the power of 2. The cube root of 64 raised to the power of 2. Now what's the meaning of cube root? The cube root of 64 means a value that will multiply itself 3 times to give us 64. And what is that value that can multiply itself 3 times to give us 64? Is what? 4. So this is now 4 raised to the power of what? 2. 4 raised to power 2 is equal to what? It's equal to 4 times 4, which is equal to what? 16. Let's look at another question. 8 raised to the power of 2 times 4 raised to power n plus 1. Then let's say we have all over 2 raised to the power of 2n. Then we have times 16. Let me say I have times 16. Then all in square root. Now, what is 8? We can write 8 as 2 raised to the power of 3. We can write 8 as what? 2 raised to power 3. So if we write 8 as 2 raised to power 3, what do we have? It means this cannot be written as what? 2 raised to power 3 raised to power 2 times. We can write 4. 4 can be written as 2 raised to the power of 2. So if 4 is written as 2 raised to the power of 2, this can be written as what? 2 raised to power 2, open bracket, n plus 1. This is all over, what do we have here? 2 raised to power of 2n times, we can also write 16. 16 can be written as what? 2 raised to the power of 4. So we can write this now as 2 raised to the power of 4. Everything is in square root. I believe we follow that. Now what do we have from our law of indices? 3 times 2 is equal to what? 6. So we now have 2 raised to power 6 times 2 raised to power what? 2 bracket n plus 1. All over. This is what? 2 raised to power 2n times 2 raised to power 4. All now in square root. We can apply the laws of indices by saying, because this is multiplying, they will do what? Their powers will add. So we now have 2 raised to the power of what? 6 plus 2 open bracket n plus 1 bracket close. All over, what do we have? This is 2 raised to the power of what? 2n plus 4. And that is what we have. Since we've got it up to this point, now let's add up these values. Let's add up these values. For us to add up these values, we are going to open this. We are going to evaluate this. Open this bracket by using 2 to multiply. We multiply 2 times n and 2 times 1. So what do we have? Look at it. We are going to get what now? 2 raised to power what? 6 plus what? We have what? Plus 2n plus 2. All over what we have? 2 raised to power what? 2n plus 4. This will give us what? All in square root. All in square root. So what we have now is 2 raised to power what? 6 plus 2 here will give you what? 8 plus 2n. All over 2 raised to power what? 2n plus 4. All in square root. We have succeeded in normalizing all the values in the numerator and the denominator. Now, still applying the principle of indices, we are going to do what? Subtract the value. So we now have, this is now equal to 2 raised to power what? 8 plus 2n minus 2n plus 4. All in what? Square root. This is what we have. The principle of indices. When we are dividing, we subtract. So we now have what? 2 raised to power 8 plus 2n minus times 2n will give us what? Minus 2n. And minus times 4 will give us what? Minus 4. All in what? Square root. So if we bring the like terms together, you can see that 2n will cancel out here. Because 2n minus 2n, they cancel out. We now have 2 raised to power 8 minus 4. All in square root. 2 raised to power 8 will give us what? 2 raised to power what? 4. And what is 2 raised to power 4? 2 raised to power 4 is equal to what? 16. Which is the square root of 16, which is equal to what? 4. So our answer is equal to 4. We have used the principles or laws of indices to evaluate this question. Let's look at this question number 3. You have to evaluate using the laws of indices. 9O number 1 over 3 times, let's say 27 O number, let me say minus 1 over 3. And let me say all over, or let me make here 1 over 2. Then we say all over 3O number minus 1 over 6 times, let's say 3O number minus 2 over 3. Let's say we have something like this. We are asked to evaluate it using the laws of indices. If we are to evaluate this now using the laws of indices, I want to solve. This will be equal to what? Our 9 can be written as this. 9 can be written as 3 raised to power 2. So if 9 can be written as 3 raised to power 2, we will now write this as what? 3 raised to the power of 2, bracket 1 all over 3. This is times our 27. 27 can be written as what? 3 raised to the power of 3. So if 27 can be written as 3 raised to the power of 3, then we can write this now as what? 3 raised to the power of 3. Then we open bracket minus 1 over 2. This is now all over. Following the law of indices, what do we have here? 3 here will give us what? Minus 1 over 6 plus minus 2 over 3. We are adding because they are multiplying themselves there. The same thing will be done for the values on top. The values on top here, what do we have? This is 2 times 1 over 3. 2 times 1 over 3. So this gives us what? 3 raised to power what? 2 over 3. This is now times 3O number. This is 3 times minus 1 over 2. This gives us what? Minus 3 over 2. All over. This will give us what? 3O number 3 raised to power minus 1 over 6, then minus 2 over 3. When our plus multiply the negative 2 over 3, it gives you minus 2 over 3. So now let's look at that. Now what do we have? This is now equal to what do we have here? 3 whole number, 2 over 3. We are adding, so this becomes what? Minus 3 over 2. Then this is all over 3 whole number minus 1 over 6. We have minus 2 over 3. Now, we are going to evaluate these fractions that we have there. Let's evaluate the fractions we have there. Look at this fraction. Let's look at that. I want to work this here. 2 over 3 minus 3 over 2. What's the LCM? The LCM is what? 6. 6 divided by 3 gives you what? 2. And 2 times 2 gives you 4. 6 divided by 2 gives you 3. And 3 times 3 gives you 9. So what do we have? 4 minus 9 is equal to what? Minus 5 all over 6. So it means our value here is what? 3 whole number minus 5 over 6. All over. We are going to find this also. Minus 1 over 6 minus 2 over 3. We look for the LCM. The LCM of 6 and 3 again is 6. 6 divided 6 is 1. 1 times minus 1 minus 1. Then we have 6 divided by 3 is what? 2. 2 times 2 gives us 4. What do we have? Minus 1 minus 4 gives us what? Minus 5 over 6. So we now have what? 3 whole number minus 5 over 6. So you can see now that we have 3 whole number minus 5 over 6 divided by 3 whole number minus 5 over 6. So when a number divides itself, the answer automatically is equal to what? It's equal to 1. But let's use indices. This will be given as what? 3 raised to power minus 5 over 6 minus, open bracket, minus 5 over 6. So minus times minus here will give us plus. We now have 3 raised to power minus 5 over 6 plus 5 over 6. Minus 5 over 6 plus 5 over 6 becomes equal to what? 0. So we now have what? 3 raised to power 0. And anything raised to power 0 for our indices is equal to what? 1. So we have succeeded in using the laws of indices. We'll take one more question. Now let's say we have something like this. Evaluate 3 raised to power n minus 3 raised to power n minus 1. Let's say we have something like this. Then let's say divided by 3 raised to power 3 times 3 raised to power n minus, let's say 27. Let me say I have 27 times 3 raised to power n minus 1. Let me say we have something like this. If you are asked to evaluate this using the principles of indices, evaluate a work like this using the principles of indices. Now let's go with that. This will be equal to what? This is 3 raised to power n minus, we can see that our 3 raised to power n minus 1 here, from the law of indices, it can be written as what? 3 raised to power n all over 3. It means they are divided all over 3. This is the same thing as 3 raised to power n times 1 over 3. That is what we have. All over what we have. This gives us what? 3 raised to power n times 3 raised to power 3, 3 raised to power n minus 27 is 3 raised to power 3 times, what do we have? This is the same thing as what? 3 raised to power what? N bracket 1 over 3. Now let's see that. What do you notice? That in this place, 3 raised to power N is common to both sides. 3 raised to power N is common to both sides of the value on top there. So we can factorize that by saying 3 raised to power N, open bracket, here becomes what? 1 minus, we have 1 over 3. And let's look at what is common here. You can see 3 raised to power 3 is here. 3 raised to power 3 is also here. It's common. So we bring it out. 3 raised to power 3. We also see that 3 raised to power N is common to both sides. So we have 3 raised to power N. Open bracket. Here will give us what? 1 minus. What is left? 1 all over 3. You can see that our bracket now is equal, so they can cancel out. They cancel out, and what do we have left? This now becomes what? 3 raised to power N all over 3 raised to power 3 times 3 raised to power N. Our 3 raised to power N will cancel out what? 3 raised to power N. We now have 1 over 3 raised to power 3. So our answer will now be equal to what? 1 all over what? 27. Let's take one more last question. Question number 5. If we are asked to evaluate 16 over 9 raised to the power of minus 3 over 2, and we are to multiply it by 16 raised to the power minus 3 over 4, then all in what? Raised to the power of 3. All in the bracket raised to the power of 1 over 3. We have 1 all over 16 over 9 raised to power 3 over 2 times, what do we have? 1 over 16 raised to power 3 over 4. Then all in what? 1 raised to power 1 over 3. That is basically what we have. This is indices. That is basically what we have. Now, 1 all over 16 over 9. This can be written as 1 all over square root of 16 over 9 raised to the power of what? 3 times. This will give us 1 all over, and we have the 4th root of 16. This is raised to power 3. Then all in what? Raised to power 1 all over 3. We have 1 all over what? 4 over 3 raised to power of 3. The square root of 16 is 4, and the square root of 9 is 3. Then this is times 1 all over, what is the 4th root of 16? The 4th root of 16 means what? What is the number that will multiply itself 4 times to give us 16? And that will be what? 2. So we now have what? 2 raised to power 3. And that is all in what? Roots equal to raised to power 1 over 3. Now what do we have? This can be written now. I write this now as what? This is the inverse. If we invert this, we are going to get what? 3 over 4 raised to power 3 times 1 all over 2 raised to power 3. Now in what? Cube root. Cube root. We look 3 raised to power 3 over 4 raised to power 3 times 1 all over 2 raised to power 3, all in what? Cube root. So the cube root of 3 raised to power 3 is what? 3. The cube root of 4 raised to power 3 is 4. And the cube root of 2 raised to power 3 here is what? 2. So what do we have? 3 all over what? 8. This is the answer to that question.